Welcome to your Algebra 2 Lesson 8.6. Today we're going to solve rational equations, so that is exactly what our objective is. So we're going to have equations today that will have rational expressions in them, and we are going to solve them. We're going to actually get what x equals. You can use cross-multiplying to solve a rational equation when each side of the equation is a single rational expression. So you want to make sure you just have one rational expression equal to another rational expression, then you can go ahead and cross-multiply. Always check your answers in the original equation. You might pick up extraneous solutions along the way. All right, so for example 1, we've got 3 over x plus 1 equals 9 over 4x plus 5, so we have one rational expression equals another one, and so we can cross multiply. So of course you write the original equation and then you go ahead and cross multiply, and so we get 3 times 4x plus 5 and 9 times x plus 1. We're going to distribute, and that'll give us 12x plus 15 equals 9x plus 9. Okay, we're going to subtract 9x from both sides to get 3x plus 15 equals 9. And we're going to subtract 15 from both sides. That gives us 3x equals negative 6. We divide by 3, and we get x equals negative 2. Now, at this point, you want to plug it back into the original equation and make sure that answer works. It does, and we're good to go, and so the solution is negative 2. Alloys. An alloy is formed by mixing 2 or more metals. Sterling silver is an alloy composed of 92.5% silver and 7.5% copper by weight. Jewelry silver is composed of 80% silver and 20% copper by weight. How much pure silver should you mix with 15 ounces of jewelry silver to make sterling silver? The percent of copper in the mixture is going to equal the weight of the copper in the mixture divided by the total weight of the mixture. And we're going to use that fact to help us solve this problem. So we're going to let x be the amount of silver added because that's what we're trying to find. Okay. We want there to be only 7.5% of copper. Okay. So that is 7.5 out of 100. That's a way of writing 7.5%. We know that 20% of the 15 ounces that exist already is copper. So that's the total amount of copper. And we want to add silver. We don't know how much, but we want to keep adding it until we get to only 7.5% of the resulting mixture being copper. So we're starting off with 20% copper, but we want to keep adding pure silver until we get to 7.5%. And so we will end up with 15 plus x as the total amount of substance, the total amount of weight in our final sterling silver, little blob or block of sterling silver. Okay, so we're going to cross multiply. So we have 7.5 times 15 plus x, and that's going to equal 100 times 0.2 times 15. Okay, if we distribute 7.5, we get 112.5 plus 7.5x equals 100 times 0.2 times 15 is 300. So we're going to subtract 112.5 from each side. We get 7.5x equals 187.5. Divide each side by 7.5, and we get x equals 25. So we need to add 25 ounces of pure silver with the jewelry silver. And so we'll end up with a total of 25 plus 15, so 40 ounces of sterling silver, and 7.5% of it will be copper, which is what you want. You want the 92.5% to be silver. All right. Now, if you don't have two rational expressions equal to each other, okay, if we had something more than just what we had here. Remember here we had one rational expression equals another rational expression. What if you have two of them on one side? Or what if you have just something else going on? Then what you're going to do is you're going to use least common denominators. When a rational equation is not expressed as a proportion, You can solve it by multiplying each side of the equation by the LCD, least common denominator, of each rational expression. All right, so what is the solution of 5 over x plus 7 over 4 equals negative 9 over x? Well, we don't just have one rational expression equals another. We've got the sum of two rational expressions equals another, so we can't cross multiply here. So we're going to determine what the least common denominator is. It's going to be x times 4, or 4x. And we're going to multiply both sides of the equation by the 4x. So the side with the plus, the 5 over x plus 7 over 4, we're going to have to distribute the 4x to both terms. On the right-hand side, no big deal. We just do 4x times negative 9 over x. Okay, so let's simplify. 4x times 5 over x, the x's will cancel, and you'll have 4 times 5 equals 20. Okay, now let's distribute the 4x to the 7/4. Well, 4x times 7/4, the 4's will cancel, and we'll be left with plus 7x. Okay, over here on the right-hand side, we've got 4x times negative 9 over x. The x's will cancel. 4 times negative 9 is negative 36. All right, so we need to subtract 20 from both sides, and we'll get 7x equals negative 56. Divide both sides by 7, and we get x equals negative 8. Okay, you do always want to check these, so you want to go ahead and plug that back into your equation, and it works. So your correct answer is B. All right, for example 4, we're going to solve a rational equation with two solutions. So it's kind of nice, our little example title gives us a little heads up there. Normally you won't know that, but you just need to be aware of the fact that sometimes you're going to have two solutions. We have 1 minus 8 over x minus 5 equals 3 over x. Again, we can't cross multiply because we have a subtraction over here on the left-hand side. We don't just have a rational expression equals another rational expression. So we're going to have to use the least common denominator method. So our least common denominator here, there is an understood denominator of 1 under the 1. And then we have x minus 5 and we have x. So our least common denominator is going to be x times x minus 5. Okay, again, on the more complicated side here, the 1 minus 8 over x minus 5, we're going to have to distribute. So we're going to have to think about multiplying both terms by x times x minus 5. On the right-hand side, it'll be a little easier because we don't have to distribute. Okay, so when we multiply x times x minus 5 times 1, we're going to have x times x minus 5. So that's where that is. When we distribute it to minus 8 over x minus 5, we'll write down our minus, and then let's see, the x minus 5's will cancel for that term, and we'll have x times 8, which we'll write as 8x. Over here on the right-hand side of the equation, the x times x minus 5, the x is going to cancel with the 3 over x, so the x's cancel, and we have x minus 5 times 3, or 3 times x minus 5. So now we need to simplify a little. So x times x is x squared, minus x times 5 is 5x, minus 8x equals, I'm going to distribute the 3x minus 15, right? Let's write it in standard form. So let's see, this would be x squared minus 13x, and if we subtract this 3x over, we'll get minus 16x, and then we'll add the 15, and we get x squared minus 16x plus 15 equals 0. All right, we have several choices here. We could factor, we could use quadratic formula, or we could actually even complete the square. Well, since factoring is an option here, and this is pretty easy to factor, that's what I'm going to go with. It's a trinomial, so you're going to have the two binomial factors where you have x and x, and we need numbers that multiply to be positive 15 and add to be negative 16, so negative 1 and negative 15. We use the zero product property to do x minus 1 equals 0, x minus 15 equals 0, and we get x equals 1 or x equals 15. And so we plug in our values, okay? If we plug in 1, it works. If we plug in 15, it works too. All right, let's look at example 5. We've got 6 over x minus 3 equals 8x squared over x squared minus 9 minus 4x over x plus 3. can't just cross multiply because we have a whole extra term on this side. So we're going to have to do the whole common denominator thing. So what we're going to do is we're going to write each denominator in factored form. So we need to think of the x squared minus 3 as x plus 3 times x minus 3, and that makes it apparent that the least common denominator is going to be x plus 3 times x minus 3. That's the denominator of this term. This one has x minus 3, this one has x plus 3, so the least common multiple is x plus 3 times x minus 3, so that's our LCD. So we're going to multiply both sides of the equation by x minus 3 times x plus 3. All right, so we're going to take this 6 over x minus 3, and we're going to multiply that by x plus 3 times x minus 3. And we're going to multiply the right-hand side. They went ahead and showed it distributed. So we're going to multiply both terms by x plus 3 times x minus 3. So let's look. On the left-hand side, this x minus 3 will cancel with that x minus 3, and we're going to be left with x plus 3 times 6, or 6 times x plus 3. On the first term, on the right-hand side, let's see, the x plus 3 cancels, the x minus 3 cancels, and we're going to be left with 8x squared. We've got our minus sign, and let's see, x plus 3 cancels with x plus 3, so we're going to have x minus 3 times 4x, or it can be written as 4x times x minus 3. All right, we need to simplify some more. We've got some distribution to do. 6 times x is 6x, 6 times 3 is 18, and that equals our 8x squared. Let's see, minus 4x times x is minus 4x squared. Minus 4x times minus 3 is plus 12x. We're going to write that in standard form. So we're going to get 0 equals 4x squared plus 6x minus 18. Those are all even, so we can factor out a 2 and divide both sides of the equation by 2. 0 divided by 2 is 0. And then on the other side, we're left with 2x squared plus 3x minus 9. Now, you might want to use the AC method. Guess and check's a little bit more complicated with this one. Just remember, you have to be careful about judging whether your middle term works or not. You have to do outside plus inside. So you would do 2x and x, so they multiply to be 2x squared. And then we want numbers that multiply to be negative 9. So basically either negative 3 and 3, or negative 9 and 1, or 1 and negative 9. Those are our choices. Let's go with negative 3 and 3 and see if when we do the product of the outside plus the product of the inside, if we end up with plus 3x. We have positive 6x minus 3x is 3x. So we factored correctly. So we're going to use the zero product property. So 2x minus 3 equals 0, or x plus 3 equals 0. So we get x equals 3 halves, or x equals negative 3. Now remember, at this point, we want to check our solutions. When we plug in our values, one of the things we want to make sure is that we don't end up with 0 in the denominator. Okay, so when we plug in 3 halves, there's no problem. When we plug in negative 3, the x plus 3 denominators are made to be 0. We can't divide by 0. So 3 halves works, but the apparent solution, negative 3, is extraneous because substituting it into the equation results in division by 0, which is undefined, right? So if I take negative 3, let's go back, and I plug it in, we're going to get 0 here, and we're going to get 0 here. We can't divide by 0, so that's undefined. We have to kick that out. 3 halves works just fine. It's a little bit of a pain to actually do the number crunching to check that it works, but it should be good to go. All right, guys, that is it. Thanks again to Larson for all the good work that they've done. Make sure you can at least attempt the problems to try on your own. If you cannot do them or even get started on them, then either rewatch the video or come in and get some help from me so that you can get those problems to try on your own done, and you'll be ready to hit the ground running when it's time to do the rounds. Have a great day. I will see you soon.